In this question, it's given that arctan x squared plus arctan y squared is equals to pi over 4, and you are required to find the derivative of this equation in terms of x and y. So for part A, these are inverse trig functions, so we'll apply the formulas that we discussed previously. So for part A, what we shall do is to differentiate this equation implicitly. So d over dx of arctan x squared plus derivative of arctan y squared will be equal to the derivative of pi over 4. Now, the derivative of arctan x, so we know that the derivative of arctan x is 1 over 1 plus x squared. Now, in our case here, x happened to be x squared, and here x happened to be y squared. So what you're going to do is to basically apply chain rule to be able to differentiate this equation, especially arctan x squared and arctan y squared. All right, so for the first case, by applying chain rule, let's start with the inside. So this will be derivative of x squared is 2x multiplied by 1 over, so I'll just write over 1 plus x squared, and the x happens to be x squared, so we square that just by applying that. And then here, derivative of y squared, we know again here we'll have to apply chain rule because derivative of y squared is 2y and derivative of y is dy over dx. So we'll have something like 2y, of course, multiplied by dy over dx. But again, if you find derivative of arctan, something is 1 over 1 plus that squared. So 1 plus y squared squared. Okay? Just similar to what we've done here. And that will be equal to derivative of pi over 4, which is just 0. So here we shall end up with 2x over 1 plus x to the power 4 plus, now here we shall end up with 2y over 1 plus y to the power 4, and this is dy over dx, and that should be equal to 0. So which implies that 2y over 1 plus y to the power 4 multiplied by dy over dx will be equal to the negative of 2x over 1 plus x to the power 4. So which means that dy over dx, so dy over dx will be equal to negative 2x over 1 plus x to the power 4 divide by that 2y over 1 plus y to the power 4. This is the same as negative 2x over 1 plus x to the power 4 multiplied by 1 plus y to the power 4 over 2y. Of course, this will cancel. So our derivative will be negative x into 1 plus y to the power 4. All this over y multiplied by 1 plus x to the power 4. So that is the derivative that is required in terms of x and y for part A. Now for part B of this question, we are required to find the gradient of this curve where x is equals to 1 over square root of 2. Now, of course, you can see here that the gradient is in terms of x and y. So if we know only the x value, we won't be able to find the gradient of this curve. So we need to find the corresponding y value when x is equals to 1 over square root of 2. So you can go ahead and say, well, when x is equals to x is equals to 1 over square root of 2, we can plug this into the original equation. Yeah, we can plug this into the original equation to find the corresponding y value. So arctan x squared, which is 1 over square root of 2 squared, plus arctan y squared will be equal to pi over 4. So that implies that arctan a half, so arctan a half plus arctan y squared will be equal to pi over 4. So, well, here we can clearly see that arctan y squared, so therefore arctan y squared will be equal to pi over 4 minus arctan a half. If you take this to the other side, so it follows that y squared will be equal to, now this is an arctan, so if arctan something is equal to something, that means that y squared would here will be equal to the tan of pi over 4 minus arctan a half. Okay, now this is the point where you know that we are trying to find the tangent of difference of two angles, and this is where you need to apply the compound angle identity. Yeah, so because you have this and that, yeah, so you can apply the compound angle identity. Um, so here we have, we know that tan A minus B, tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So our A in this case will be pi over 4 and our B will be arctan a half. So which implies that y squared, which we have here, so y squared, I can just write here, so y squared will be equal to tan pi over 4, because that's our A, minus tan, and we have arctan a half for our B, over 1 plus, okay, so our A again is pi over 4, and our B is arctan a half. Okay, now one thing that you need to understand is that tan of arctan, those two cancel each other out, so you just end up with a half. So, and also tan of pi over 4 is same as tan of 45 degrees, and from special triangles we know that tan 45 is 1. So this will be equal to 1 minus these two cancel, so that will just be a half, and then we have 1 plus this will be 1 and that will be a half, so you just end up with a half. So this will be equal to a half over 3 over 2, and that will be equal to a third. So we can see now that y squared is equal to a third, which means y will be the square root of a third. So it follows that y is either square root of a third or positive square root of a third, or y is negative square root of a third. Now, from the question, it stated that y is less than 0, so which implies that y is negative a third. So when x is equal to 1 over square root of 2, y is equal to negative square root of that, because y is less than 0, a condition that's given in the question. So now we can go ahead and substitute these two into the derivative to find the gradient of the curve at that point. So dy over dx will be equal to negative x, which is 1 over square root of 2, multiplied by 1 plus y to power 4, which is negative square root of a third to power 4, over, and you have y into bracket 1 plus x to power 4. So again, y is negative square root of a third multiplied by 1 plus 1 over root 2 to power 4. All right. So here outside we'll just have negative 1 over root 2, and then inside the bracket we'll have 1 plus a ninth. Actually, I think I can just use brackets now. And then down below here we have negative square root of a third. Then we have 1 plus a quarter. And this will be equal to negative square root of 2. So 1 plus a ninth, that will be 10 over 9, over here we have negative square root of third. And here, not really. Yeah, I mean, you can write it that way, square root of a third. And this is just the same as, I think it's better if I write it this way, root 3. Because this is just a square root of 1 is just 1, and then, And then this will be 1 plus 1 over 4, that will be 5 over 4. Okay, now, when you divide these two, this is same as multiplying the reciprocal of this. So this will be equal to square root of 3 over square root of 2. And then if you divide these two, that will be 8 ninths. So basically our solution will be 8 root 3 over 9 root 2. And that will be our final solution.